In this video, I'm going to run through a wonderfully simple way of finding the pKa and the Ka just by looking at a titration curve. And so let's start by looking at the maths that underlies this method so you can understand why it actually works. So fundamentally, it's all based on the Henderson-Hasselbalch equation that tells us that the pH of a solution is equal to its pKa plus the logarithm to the base 10, it's always the base 10 logarithm, of your concentration of your conjugate base divided by the concentration of your conjugate acid. Remembering that those square brackets simply mean concentration. Now we're going to look at a very specific case. So let's imagine that we have the situation where your conjugate base concentration is exactly the same as your conjugate acid concentration. So basically, in that division, we have the same number on the top and the bottom of the fraction. So that's going to simplify down to 1. So therefore, we can say that in this special situation, we've got the logarithm of 1 on the end of that equation. And if you put in your calculator log to the base 10 of 1, you'll get 0. So therefore, in this specific situation, this is going to all simplify down to the pH being equal to the pKa. So in this situation, if you knew the pH and you could say for certain that the two concentrations were the same, you can just read the pKa straight off of the graph. So the next step is to think about, if you know the pKa, and I'm going to show you how you can get that from the graph in just a second, you can get the Ka almost straight away. So the pKa is simply equal to the negative log to the base 10 of the Ka. And if you rearrange the logarithm, you get an equation for Ka that's simply that the Ka of the acid is equal to 10 to the minus pKa. And so that's a really quick way, once you have one, to get the other one. So really all we have to worry about is finding the pKa. When we have the pKa, we just get the Ka straight away from that equation. So let's look at a titration curve. And the first step is you need to find the equivalence point. So I've got a titration here of acetic acid being titrated with sodium hydroxide, and you get the curve looking like that. The first thing you need to find is the equivalence point. And the equivalence point is where you've got neutralization going on, and it's going to match up with that bit where the graph shoots up in a straight line. So you take that and you read right down the way, and that's giving a volume of 10. And it's actually 9 point something, but we're just taking it for 10 right now. Then the next step is to find the half equivalence point. The half equivalence point is going to be really useful. This is where we're going to read our pKa. The half equivalence point is actually really simple to find. It is simply half of the equivalence point. So our equivalence point's happening at a volume of 10. So the half equivalence point is a volume of 5. And you can just read across at 5. So take whatever your reading is for the equivalence point, half it, and then put a mark there. And then you just simply read across. And when you read across, you can read off the axis and you get a pH of 4.75. At the half equivalence point, you have this magic situation we looked at previously, where your conjugate base concentration is equal to your conjugate acid. You're halfway to being neutralized. And so that's what you can say at the half equivalence point. So therefore, that 4.5 we're reading off of the pH, because of that simplification we looked at the beginning of this video, means that 4.75 is our pKa. So we can actually calculate everything that we need. So we know that the pH is the pKa at that special point. So therefore, the pKa is 4.75. We previously derived the equation that the Ka is simply the 10 to the power of minus pKa. So you just put that into your calculator and you've got the Ka. Very simple. So I hope this video was helpful to you. If this video did help you out, please like and subscribe below and look at my other chemistry videos. Hopefully they will also help you out. And finally, thank you very much for watching.